As an overview, we introduce you to K terms through an example, and then we examine the relationship between AI, machine learning, and deep learning. And then step by step, we dive into AI in healthcare and the techniques that used in skin cancer detection. So I want to talk about the game Go. For those who don't know the Go game, it's an ancient Chinese board game. It's a very old game. The surprising fact is about that game is there is a 10 to the power of 170 possible board configuration. This number is more than the number of atoms in the universe. I wanted to mention that because the word number one is an AI program developed by Google DeepMind, which named AlphaGo. Actually, this version, which for some, I'm sure that you heard about in 2016 event, AlphaGo beat the 18-time world champion Lee Sedol. But how does it work? Go depends on human intuition directly, but how can an AI program, a machine basically overcome this problem? Through two networks, which called deep neural networks. These are policy networks and value networks. Policy networks basically tells us what the possible, what moves are promising are in the current board, as you see here. And then the value network is examine and calculate the value, how good the board position is selected. But since the search space is so big in this game, we couldn't analyze all possible configurations iteratively. So for that, we use Monte Carlo tree search algorithms to prioritize the suggested moves. For some, of course, obviously for Lee Sedol, it's a bad news, but it is an exciting news for the science, for the sake of science, because it seems impossible for next 10 years for an AI program overcome this problem, overcome such a big number of search space. So we talk about actually some techniques and some approach for AI, machine, and deep learning above example. We are clear about that. Artificial intelligence is any technique that enables computers to mimic human intelligence, basically. And machine learning is a subset of artificial intelligence, absolute statistical techniques that enable the computer perform the task through according to its experience. So deep learning is the subset of machine learning. It composes algorithms that permit software learn itself. So the computer learn by itself, by playing itself, actually, for the above example. So with this example by itself, it is enough to stress the importance of AI in today's world. And these approaches, what we see above in the example, could adopted by alike approaches could adopted by many industries in the current or other areas, actually. So one of them, which we'll focus on, is a healthcare industry, because it could even save lives. We could even save life with these approaches, same as we use in or alike approaches, same as we use in Go and AlphaGo. So as I say, it could save lives and benefits for healthcare industry.
AI in healthcare. Artificial intelligence and machine learning hold considerable promise for the field of health, right from hospital care, data entry, inpatient and outpatients, and insurance. AI applications are reform how the industry works as a whole to cut down on costs and significantly improve patient outcome. The change in AI's apparent accuracy rate in the practice has greatly increased. The most importance of this industry. One of the areas where AI in healthcare has shown the most promise is in diagnosis. Early diagnosis is one of the most important factors in the ultimate outcome of the patient's care. AI deep learning algorithms are being used to shave down the time it takes to diagnose serious illnesses. The way AI rapidly processes large amount of information and arrives at likely causes for symptoms can drastically reduce the diagnosis treatment recovery cycle for many patients. The effects of this are already being felt in several areas. Image from pediatric biopsies and distinguish environmental atrophy from celiac disease more reliable than human doctors, at least at the early stages when the two disorders are easily confused. It is hoped that this could speed up treatment of children and reduce standard growth rates that could be the result of delayed diagnosis. Also, we can show the example of AI in radiology with epilepsy. Together with Osaka University, it was achieved that people's brain magnetoencephalography reports were collected and pre-diagnosis of epilepsy was easy. AI uses some methods to diagnose diseases. CNN is the most modular method of processing visual findings. CNN forms the perspection mechanism in the computer, just like in humans. Thanks to CNN, the diagnosis of the disease can be made by AI. The captured image is processed and printed out. The most accurate results can be reached by comparing with previous. As the number of the data obtained increase, the accuracy of results will increase. Here, we see the graphic of Sebastian Thrun's research. Doctors' diagnoses are compared against CNN's diagnosis for skin cancer. Accuracy rates are derived. The red dots show the dermatologist's accuracies, while the green dots gives the average accuracy value. The blue line gives the accuracy rate of AI. Although the research includes good dermatologists in their field, it is seen that the average diagnosis is insufficient against AI. This rate that can cost many people's lives. So how does AI achieve this with CNN?
Now we will look at CNN algorithm, which is used skin cancer detection, a system that analyzes the image coming from a person with skin cancer with CNN and separate them into disease types and gives probabilities. First, we get input. And we have two stages, feature learning and classification part. Feature learning has a two layer, convolution layer with replication function, and also pooling layer. Classification part has a three layer, flattening layer, fully connected layer, and softmax layer. Why convolnet over feed-forward neural nets? Because a convolnet is able to successfully capture the spatial and temporal dependencies in an image through the application of relevant filters. The network can be trained to understand the sophistication of the image better. The role of the convolnet is to reduce the image into a form which is easier to process without losing features with critical for getting a good precision. Looking at this picture, there's a difference that are difficult to understand at first sight. However, when we give matches this structure as a matrix, we make it possible to capture even the smallest detail. It learns the effects of these differences on the label during the training phase and then make predictions for the new pictures using them. Convolutional neural network has some layers to perform these operations effectively. First layer is convolution layer. This layer is the main building block of CNN. It is responsible for perceiving the features of the picture. This layer applies some filters to the image to extract low and high level features in the image. For example, the filter can be a filter that will detect edges. These filters are usually multidimensional and also contain pixel values. We determine our properties by moving the filter over the image and using simple matrix multiplication. The output matrix is often called feature map. It shows where the image is located in the property represented by the filter. Usually more than one filter is used to detect multiple properties. In the padding part, in the early stage of CNN, while applying the first filter, we need to preserve as much information as possible for the other convolution layers. Padding is used for this reason. There are two types of result to the operation. One in which the convolve feature is reduced the dimensionality as compared to the input, and the other in which the dimensionality is either increased or remains the same. Since all layers can be a linear function, the neural networks behave like a single perception. So the result can be calculated as a linear combination of outputs. This layer is called also activation layer. because it uses one of the activation functions. In the past, nonlinear functions such as sigmoid and tan were used, but since the rectifier function gives the best result for the speed of neural networking training, this function is now also used. In the pooling layer, there are two types of pooling, max pooling and average pooling. Max pooling returns the maximum value from the portion of image covered by the kernel. On the other hand, average pooling returns the average value from the portion of the image covered by the kernel. Max pooling also performs as a noise suppressant. Hence, we can say the max pooling performs a lot better than the average pooling. In the second part, classification part, this part's first layer is flattening layer. The task of this layer is to prepare the data at the input of the last and most important layer, which is fully connected layer. Generally, neural networks receive input data from a one-dimensional array. The data in this neural network is conversion of the matrix from the convolutional and pooling layers into one-dimensional array. In the second layer, fully connected layer, the flattened output is fed to feed-forward neural network and back propagation applied to every iteration of training. Over a series of epochs, the model is able to distinguish between dominating and certain low-level features in image and classify them using the softmax classification techniques. In softmax is mainly used to normalize neural networks output to fit between 0 and 1. It's used to represent the certainty probability in the network output. The normalization is calculated by dividing the x value of the examined output by the summation of the x value of each possible output. This application is used in skin cancer diagnosis and helps us label diseases. This system provides great benefit for both people and also the system.
Hi friends, I want to talk about financial change in the future in artificial intelligence and briefly. And all associated healthcare market is expected to grow rapidly and reach the $6.6 billion US dollar by the 2021. Corresponding to 40% compound annual growth rate. And then I want to focus on the two topics of the future artificial intelligence. One of them is computer vision for diagnosis and the surgery in the future. In areas where computer vision is making an important impact to include image-based and diagnosis and image-guided surgery, the computer vision has mainly based on the statistical signal processing, but it's not a shifting more toward application of artificial neural network as the choice for a learning method. Here, deep learning is used to engineer computer vision algorithms for classifying images of the lesion in skins and other tissues. And video data is estimated to contain 25 times the amount of the data from the high resolution diagnostic images such as CT, and it could thus provide a higher data value based on resolution over the time. And then video analysis is still premature but has a great potential for clinical decision for support. And as an example, video analysis of a laparoscopic procedure in the real time has resulted in 92.8% accuracy in identification of all steps, the procedure, and surprisingly the detection of missing or unexpected steps. And guys, I want to focus on the other feature, artificial intelligence. It is a precision medicine, and I will explain about how about the precision medicine in the future. The tailor-made treatment opportunity will take into consideration the genomic variations as well as contributing factors of medical treatment, such as your age, your gender, and your geography, your race, family history, immune profile, metabolic profile, microbiome, and environment vulnerability. So it covers all your what I'm saying. And the objective of the precision medicine is to use individual biology rather than the population biology at all stages of patients' medical journey. Innovation in precision medicine is expected to provide great benefits to patients and change way the health services and deliver it and evaluate. And in precision medicine, there are many types of precision medicine, but we can focus on the three of them in clinical areas. And one of them is complex algorithms. The other one is digital health application, and last one is omics-based test. It's basically collect your body and disease information. And digital, let me introduce the digital health applications. The healthcare apps record and process the data added by patients, such as food intake, emotional state or activity, and health monitoring data from wearable, for example, mobile devices and your Apple Watch, something like that. Complex algorithms, machine learning algorithms are used with a large data sets such as genetic information, demographic data, electronic health records to provide a prediction of prognosis and optimal treatment strategy. And the last one is the omics-based test. There are a lot of research on omics-based test. I want to introduce what is the omics-based test. It is the genetic information from a population pool is used with machine learning algorithms to find the correlation and predict the treatment responses for the individual patient. In addition to genetic information, other biomarkers such as protein expression, gut microbiome, and metabolic profile are also employed with the machine learning to enable personalized treatment. When we conclude these three things, the foundation of the precision medicine have actually been laid, but it needs more time to take its final form. In the future, we will see these three types procedure result together in all our bodies. Thank you listening for us. Do you have questions? We are here to answer your questions.